Okay, in this presentation we are going to look at the Poisson distribution. So it's a quick tutorial question. This is part of the discrete probability distribution sort of series of tutorials that we are looking at. So the question is as follows: given that x is a Poisson random variable with an expected number of occurrences, lambda equal to 2 in a 1 hour time period. Not that it's important this time, but in other questions you have to watch that time period or unit space because it can move around from question to question. Okay, so for example, in a 1 hour, in a half hour period, lambda would equal to 1. So yeah, just remember to adjust it. It's not really relevant in this case. I'm just digressing just to sort of remember to read the question properly. Anyway, I'm digressing. Let's move on. So we can use the properties of the Poisson distribution to answer these questions. So we have these exercises here. Compute the probability of no occurrences in a 1 hour period. That's question A. And question B, what is the probability of 2 or more occurrences in a 1 hour period? Okay. And question C is a theoretical question. Suppose y is a random variable that describes the amount of time between occurrences. What is the probability? Which probability distribution should be used to describe y? Okay. So anyway, here we have the probability mass function of a Poisson random variable. So this is an important formula that you really should get used to very quickly. Okay. Probability of x, which is x is essentially a notation for number of occurrences, and equal to k, where k is some integer value between 0 and, well, it's not up, it doesn't have an upper bound, so let's say infinity. Okay, that is equal to lambda to the power of k, that's the parameter value, the rate parameter, times e of the exponential of minus lambda, e to the power of minus lambda, divided by k factorial. Okay, so e to the minus lambda, the exponential of minus lambda, stays consistent on as long as lambda stays consistent. So worth making a note of it. It probably stays the same from question to question in the same setup. Anyway, so all we have to do is compute the probability of x equal to k, or sorry, k equal to 0, which is no occurrences. So that is the probability of x equal to 0. So 2 is lambda, and lambda is equal to 2, so we have 2 in there. So k is equal to 0, so we have 0 in there. So we have 2 to the power of 0. Anything to the power of 0 is automatically 1. So 2 to the power of 0 is 1. We have the exponential of minus lambda, which is the exponential of minus 2. Okay, so far so good. And divide that by k factorial, which is 0 factorial. Now, something to remember, particularly when you're doing Poisson distribution questions, is that 0 factorial is always equal to 1. Okay, so what we have here is the exponential of minus 2 as the answer, which is 0.1353, 13.53%. Okay, so make note of that because we're going to use that in the next exercise. What is the probability of 2 or more occurrences in 1 hour? Okay, to find the probability of 2 or more occurrences, we subtract the probability of 0 and 1 occurrences from 1. Okay, it's the complement rule essentially. So the complement of 2 or more occurrences is 0 or 1 occurrences. Okay, so essentially that is the approach we will take to answer this question. So what we're going to do is calculate the probability of x equal to 0, which is actually something we've already done in the previous question. So we're just going to use that result again from exercise A. Add it to the probability of x equal to 1, okay, which we're going to do there shortly. Add them together and get the complement of that to find the probability of x greater than or equal to 2. Okay, so let's proceed. So we have to find the probability of x equal to 1. That's k equal to 1. So we have 2 to the power of 1 times the exponential of minus 2 divided by 1 factorial. Okay, 2 to the power of 1 is 2. 1 factorial is also 1. So we have 2 divided by 1 times the exponential of minus 2. The exponential of minus 2 is actually a value we've already calculated in the previous question as well. It is 0.1353. So essentially 2 times 0.1353 gives us 0.2706, 27.6%. So that's the probability of 0 or 1 occurrences is essentially 40%, 0.4059, okay? But what we want is the complement of that, which is the probability of 2 or more occurrences. So essentially, we get the complement of that 40%. 1 minus 0.4059, and that gives us an answer of 0.5941. Okay, so that is the answer to the second one. And finally, this is the last part. Now, this is essentially a theory question. So, suppose y is a random variable that describes the amount of time between occurrences. What probability distribution should be used to describe y? Okay, what the time between occurrences for a Poisson process follows a exponential distribution. Okay, so essentially the time periods between occurrences in a Poisson process is a probability distribution modeled as the exponential distribution essentially. So given the rate parameter lambda equal to 2 occurrences per hour, the exponential distribution with rate parameter lambda equal to 2 is appropriate to describe y. Okay. So essentially we're using the same parameter in the Poisson distribution as in the exponential distribution, and so essentially we're going to parameterize our exponential distribution with lambda equal to 2. That's essentially the theory question there, just actually to remember the connection between these two distributions. So let's just flesh it out. Y is an exponential random variable with mean duration lambda equal to 0.5 hours. Okay, so that makes sense. If you're expecting 2 occurrences in an hour, that means you're expecting the occurrences to be approximately spaced out by about half an hour, 0.5 hours. Okay, and that gives us our mean. The mean time between occurrences should be about 30 minutes. So mu is equal to 30 minutes. So the exponential mean there, mu, is 30 minutes. The rate parameter is equal to the Poisson mean, i.e. lambda equal to 2 per hour, or equivalently 1 over 10 when denominated, or 1 over 30 when denominated in minutes. Okay, which makes sense. So just, you can be a little bit careful about switching between hours and half hours and minutes, particularly when you're dealing with the exponential distribution. We'll stick to hours here for the time being. Okay. So the density function of the exponential distribution is given as follows. F of t for the y distribution equal to lambda times e to the minus lambda t. For this particular case where lambda is equal to 2, we have 2 to the exponential of 2 times the exponential of minus 2t. So anyway, y is an exponential distribution with lambda equal to 2. Okay, and again, really this is just actually a theory question that connects the Poisson distribution to the exponential distribution, so because it's important to know the connection between the two. That's it. We'll leave it there.